For this question, we have a piecewise function. There are three pieces over here. So I'll start with the first piece first. And it is a quadratic graph. And for this quadratic graph, I got that my A is a negative. So this quadratic graph will be a set graph. So now I can start drawing my graph. So over here, my graph will look like this. So this is 2. But if we check the domain, this graph only happens when my x is less than or equals to 0. So this means that my graph will only be at the left-hand side of x equals to 0. So I now need to change. So this graph will only look like this. At the right-hand side, when it is greater than 0, there is no graph. So that is my quadratic graph. Now I'll move on to the next graph, which is x plus 4. For x plus 4, it is a linear graph, and over here the gradient is positive, so this graph will be a straight line going up. So now when I have checked the domain, so when x is equals to 2, so now this is for the graph of gx equals to x plus 4. So g of 2 will give me 6. So here, when it is 2, this is 6. So this one will be a shaded dot because there's equality. And then the next one, when x equals to 6, I have g of 6 to be equal to 10. Okay, so now I have to pull my scale up a bit. Okay, you use your ruler and draw it to be a straight, make it straighter. So now I have 6 and 10 over here. So here my dot is also shaded because there is equality sign. So now we will combine these two dots. We know this is a straight line going up because it is a linear graph. Okay, now we do the last piece. The last piece is this function here, also a linear function. My gradient is positive, so it will look like a straight line going up. So now we look at the domain. This time, I have my function gx equals to 3x. So when x is equals to 6, my g of 6 is equal to 18. So here I have, when x is 6, my gx is 18. So over here, this will be a non-shaded dot because there is no equality. And this is a straight line going up, so my graph will continue to go up. So this is the shape of my graph. Okay, so we are now going to label our graph. So this is my third piece, that is gx equals to 3x. The second piece, that is gx equals to x plus 4. And this is the first one, which is gx equals to 2 minus x squared. So from this graph, I can read my domain and my range. So domain, I look at my graph, base it on the x-axis. So the most left, this graph will continue to go to the left-hand side, so there's negative infinity. And then it stops at x equals to 0, open, and then it touches x equals to 0, so it's a closed graph. Then after that, at the right-hand side, there is another set of answers, so I'll use union. So this time, it is from 2 to 6. Close, close. But then over here, if you see, I have a shaded dot above. I have a non-shaded dot. So this graph will continue to go to the right-hand side. So this means that over here, if I read my graph carefully, this will approach positive infinity at the right-hand side as it goes to the right-hand side. Okay, that is for domain. Now we will do our range. So for range, we look at our graph. We base it on the y-axis, at the gx-axis. So the most bottom, this graph will continue to go down to negative infinity. Then after that, it stops at 2. It touches 2. So this is open, close. Another set of answer. Okay, between 2 to 6, there is no graph. But then at 6, it will continue to go up until 10. So both sides are square brackets because the dots are shaded. And lastly, I have, as we continue to go up, it will start at 18 and then continue to increase towards positive infinity. So at 18, my bracket is open because my dot is not shaded. Okay, so that's the answer for domain and range.